So let's close up this edition of Lambda World with a debate. And the question is really simple. Does functional programming still matter in the area of AI? And I know that they are functional programming lovers, but the intro of this event was totally the opposite. Look at you. You are very few people. AI is killing you, and you know that. So I need them to really explain me why. Why should I believe you? Why it still matters? If year after year there are less functional programmers, why it still matters when companies don't care at all about functional programming? Just contact them. Tell them, come to my event. No, I don't care about that. Go to Silicon Valley to raise money for functional programming. Good luck with that. Yeah? So, okay, I'm going to give the micro to Raul so he can explain us, because he's crazy. He's going to start a new startup about functional programming with AI. So let's see how it goes.
I think that companies don't care about functional programming. That's true. For the same reason that you shouldn't care about functional programming, because it's not an end goal. It's a means to do something, right? We use functional programming to create safer code, to have a certain set of guarantees, to better understand our code. But it's not the purpose in why we do projects or things. Is functional programming relevant in the age of AI? I think from many angles, yes. For example, we discuss at length in many talks in the hallways the role of verification in the industry. Functional programming is very close to that. If not, you would call it the same thing with different names depending on what you're focusing on. And that is going to be relevant. Why? Because how many of you use or have used AI for coding today? Please raise your hands. How many of you are actually happy with the outcome you got from the AI? Right. So there is definitely a problem here, right? And how many of you plan to stop using AI forever and will never look at it again for their coding task? Okay, one. So the exception that confirms the rule. but my point is, you're not going to give up on it. You're still going to use it. Right now it's shit. You don't like what it does, but we have to fix it. And I think a lot of the industry effort is being focused right now on making LLM architecture like the transformer architecture, neural networks and so on. Let's call it not so open, but more like predictable in terms of like how they do inference. But that's not the solution, because at the end of the day, AI will not have all the context you need to solve your problem. So for your programming problems, for your projects, even if they're not programming related, AI, it's important. It's what is becoming part of the tool set. As functional programmers, we have a privileged situation because we understand what makes programs incorrect and what makes code incorrect. And I think we should look into solving those issues so that we can have more reliable AI generation. But I don't think AI will kill functional programming. I just think that functional programming doesn't need to be killed because it has never been the goal. It has always been a technique and a craft that we understood, but it shouldn't be the purpose of our career. Or we use functional programming to achieve other goals. What are those? Can AI also help in that same place? I think so.
Okay, before we move to if someone else wants to add something else, we are going to add the Q&A, okay? So if anyone wants to add a question for the debate, please do it through the Bebox app, and we will add it right after this question, okay? Go on, Jack.
So I think there are two scenarios. One is where AI continues to improve, new models are found in addition to LLMs, and we see its continued growth on capabilities. If that happens, I think it's pretty existential to functional programming and to niche programming languages in general. And the reason for that is they're basically probability machines on training data, and that most of that training data is bog standard OOP. And the solution to a problem that LLM will give will be tightly coupled to what is the culture of a company and the training data they've given, and what is the wider set of training data, which functional programming is a very, very, very small part of. So I think it would be bad for functional programming overall if that were to happen. I think the more likely scenario is that improvements in the current models of AI become pretty marginal. And the people stop drinking the Kool-Aid, the money dries up, and we just continue as we are. And we can continue coming to Cadiz and having a good time. And functional programming will continue to be a going concern. I think that's much more likely based on what I've seen and the utility of these coding assistants and LLMs. They might give you some rough idea of how to solve a problem, but then they're not there yet on actually giving you a working solution that you could productionize, in a big company. It just doesn't work like that. So, yeah, I think there's broadly two flavors there. It just depends which one you think is more likely.
Okay. Isaias?
Well, I give 2 points there. I think the AI has learned to talk, but not to walk yet, and maybe to jump on that bandwagon. It doesn't have the context in order to explain all the problems that we face in real life. So it doesn't have a real life understanding yet. And unless we don't have that exposure to the other parts of our lives, we will have to translate and interpret the customers, the client's needs that don't speak tech. They can say, oh, I want this button to be green, but that's maybe not what they want. So we still are needed. And FP seems to be the, let's say, superior solution in order to state the problem or solutionize the problem. Seems also that, LLMs have a better tendency to answer those questions in the FP space. And so that's mainly one of the main topics that we're facing, that they're even good at proposing solutions in the FP space. So if I can't make a problem, if I can't make, let's say, let's call the famous null problem, right? If this is eliminated by language design, then the AI can't make this problem either. So FP and language design is still very important. That's what I think.
Okay. Anurag?
So, obviously I'm going to say similar things, but I actually have a very different perspective on this, which is, it's not just a question of whether functional programming is relevant. You can say this about every programming paradigm there is. You can ask the same question and you will get, the same answer from the defendants of those paradigms. Yes, it's important for such and such reason. You take any framework. Is PHP important anymore? It's not. Is JavaScript important anymore? It's not. Right? So the question sort of then becomes, okay, if AI is the programmer, what should we design into AI's code generation that helps us the most as humanity? Right? And when I look at that question, to me, the proof of correctness of what the AI is producing is the most important thing for me. Because if I don't have that proof of correctness, then I cannot trust anything that the AI produces. The only solution I know today for getting proofs of correctness is to construct those programs in this very nice compositional manner that we have learned how to do in functional programming. And so to me, functional programming is sort of the obvious solution for producing AIs that produce reliable code. Okay. And it doesn't really matter what humans think of that code. I know that I can produce verifiable code from the AI, and then if it works, I don't care beyond that, whether it was a functional program or a JavaScript program or whatever the hell it was. Right? So I sort of see functional programming not so much as what we think about it as humans. I mean, we as humans sort of came up with this concept that, we need this mathematical grounding for programming. Because there are some sets of humans that believe in it. There's a very large other sets of humans that don't really care about it. But when I take it from an AI perspective, I almost require that it needs to be provable that this is correct. And the only way to do it today, based on all the bodies of knowledge we have, is functional programming. So that's where I come from. It's a solution that is the obvious one.
Okay, so we are starting to get some questions. Next question is, do you think functional programming and other declarative paradigms might eventually see a new growth phase as AI keeps becoming better at generating code and we as developers shift our focus to working with the requirements and specifications? Anurag, you can answer this one.
Like I said, so one of my observations about functional programming in general is that it's not that, remember I come from a Lisp world, okay? And everybody asks me, why do you keep programming in Lisp? Nobody uses Lisp anymore. I tell people, look, it's not just that, everybody is using Lisp today. Every single programming language that is out there in popular usage, you can trace its origins back to Lisp. And features that were introduced in Lisp and now are getting out there. And so it's the same thing with functional programming. Every other language out there is slowly getting more and more functional, right? And that's just how, people have sort of understood that the more complex your programs get, the better it is for you to use functional programming, right? We're now at a different stage where our tools have gotten to the point where we have to interact less with the final code and we have to sort of interact more with the specifications that we're creating for that code. And so will FP see a growth spurt? I think yes, in the form that it might get more absorbed into other languages, as it does today. But more than that, I think that it's somewhat not so important that it sees a growth spurt. I think what's important going forward is that the machines that we are building to generate this code incorporates the right language. And we may conclude that it's not a functional language at the end. We may still come up with a very simple, verifiable language that is not functional. I don't know. Maybe that's the case, but it doesn't seem that way today. So it's hard to say whether we'll see a spurt or not. On the other hand, functional programming has been steadily increasing. Usage of functional features in other languages has been steadily increasing for the last 35, 40 years.
Yeah, I think I agree mostly. So for the time when I'm looking back the last 2 years, maybe do a quick rewind, starting to use all the features that those tools have. The intervals between the times that I have to interact is getting always increasing and increasing. And sometimes I go for a coffee and come back and I think like, oh, that's not meeting the spec, not at all. And it's going off rails very quickly sometimes. But the more specific I am on the paradigms and also the more it meets to the problem statement at hand, the better usually also the outcome is going to be. And for almost all the times I've been observing that when I'm explicitly stating a specific solution, like maybe taking a reducer, a state machine, something finite into account, streaming or whatnot, then things tend to be just very, very closely to what I had in mind. Or then it's taken off just a lot of the relevance of picking other topics around it, like different paradigms maybe, or focus on, okay, let's maybe put an imperative thing in here just very specifically. But most of the times it's very well handled by FP solutions, just very, very high level. And so maybe it's getting a bit more or less relevant for the other paradigms.
Okay, let's move to another question. This one, let's pass it to Raul. How do you think? Sorry, they changed it just a moment. How do you think formal methods verification will evolve with AI?
I think currently there's tons of like different formal verification tools that have been built kind of ad hoc for specific problems around. Some of them verify state-like machines, other ones verify logic. There is all kinds of like different purpose tools, but there isn't one yet that covers the use case of generative code or AI generating code potentially in any language, or taking an existing code base and then working with it from a language you don't have control over, where you cannot just create your pure subset of the code that you can verify. I think those are still open challenges, and I foresee a future where some of these verification tools target more the kind of workflow we're going to follow as developers and as we interact with AI generation tools. So definitely what I see is a future where some of these tools acknowledge AI is there, the code is generating might be outside of the subset. Many other features that would ultimately kind of make the code generation more of like a deterministic or more of a predictable process that you can actually sit down, verify. So yeah, I think they will change. I think right now they're way too specific and there are too many in many different languages and ecosystems. So when you want to do verification, you're essentially having to use a myriad of like many different kinds of tools that really don't solve that problem in particular. You're just using them for different parts of the problem. So I see that there will be awareness. And the reason we were talking earlier is like, even if the models get too good, even if ChatGPT gets too good at code generation, still not going to perform that verification step that the semantics of what you've requested or you expect are actually what's being coded. So I think that step is critical and that will affect the way code verification tools operate in the industry.
Is there any disagreement here, or?
I think formal verification, and the other side of that is you have to be very, very specific on the specification of what you're passing into an LLM for code generation. And I think those two things combined will mean, are you actually saving any time? And are you saving any money? Because if you're having to be very, very precise, and then you've got to do this formal verification step, the time it's taking you to do that, you might not have saved any time, in terms of dollars, doing that versus actually just coding it by hand. And formal verification is so outside the vocabulary of what I encounter day to day. Much more likely is we just accept the risk of deploying LLM generated code straight into production without any verification.
Okay, I think Anurag had some things to say.
Oh, yeah, I mean, it's actually sort of similar to what Jack just said, which is that the worst part about formal verification is that you as a human have to sit and do it. If you've ever used these proof assistants and, ACTA and all of that, it's great for small examples and in moderately sort of big examples. But it is, I can't imagine sort of sitting there with a proof assistant every step telling it what to do this, do this, do this, do this. I love the fact that we are now entering this world where you have these hybrid LLM proof assistant models where the proof assistants and LLMs are talking to each other. So I don't have to write the proof. or I don't have to assist the proof. Either the LLM can keep assisting tactics until it actually gets to a proof. So going back to what Jack just said, today we just accept the risk of it being, that the LLM might have generated some bad code. But I think there's a way out in the sense that, the LLM is helping you. There's one LLM that's helping prove it. There's another LLM possibly that's generating the code. And then there's a proof checker in the middle that's mediating, what's going on between these two things. So I sort of feel like now is the time for formal verification methods to actually shine, because you don't have to put so much work into it.
Okay. Let's move to another question. Isaias, how do we ensure the correctness? Very few developers know about any form of formal verification.
Well, the formal verification methods often take away some freedom from developers. These restrictions that we get from the formal verification methods are oftentimes accompanied with inconveniences. And that's maybe the window where the AI can maybe fill the gap. And not 100% sure I get the question entirely. Ensuring correctness, yeah, that's going to be a hard one.
Any of you want to answer this one?
Do you mind if I go again? Or
Go
again.
Yes.
Who wants to go first?
Raul?
Yes, very few people know about formal verification. This is a limitation of our education systems. Computer science programs today are designed to produce skilled coders, not skilled specifiers. So, we don't focus that in terms of an educational program to sort of think about building programs that are verifiably correct. We never taught that. I only learned it because, I happened to go to graduate school where there was a little bit of focus on that. But we don't teach that. And that has to change because, if you remember my diagram from this morning, we produce skilled coders today, but skilled coders are going away. And now we need to start producing, either technical specialists who really just rely on AI to do everything, or we have to produce, system engineers who really understand the system from end to end and have the mathematical background to produce things that are verifiably correct. So I would sort of say, look, don't think about it in terms of the short term. Think about it in terms of the next 10 years. And, if there are academics in the room, go back and, redesign your academic programs so that we're producing people who actually, can work with these types of systems.
Okay, let's pass the mic to Jack. At what level, in your opinion, will software engineers be integrated into the process? At the level of writing proofs for functions and interfaces, or more like vibe coding?
If I count the hours that me and my team spend actually coding in a given year, it's quite a small fraction of the time, right, in actual build. The problem is consensus, design, agreeing what it is that we're going to build. And these are social problems. Agreeing with other stakeholders, teams, lines of business, what it is we're doing here. LLMs have nothing to say about this. Nothing, right? They do not understand or can hold in their context all of the functional complexity that we have. So yeah, we could probably, have some formal methods and, a good way of getting LLM generated code into production, going through all the regulatory procedures that we have to adhere to with code. But it's a small fraction of what we do. We solve problems and we write code to solve problems, and the definition of those problems, the specification of them, the design, and everything else is a human thing. And so where we're integrated into that, if you can take away some of the build, fine, but from a percentage of my time spent this year, like, it's hardly anything, right? And I don't think artificial intelligence has much to say about the way in which I spent my time and what I've had to do, basically.
Raul, do you have anything else?
No, I just mentioned that also I agree completely with Jack in the sense of like, yes, we spend really in practice, especially when you're working maybe in a larger team or something, less time coding and more time like agreeing and getting together into a common understanding of what needs to be done, what's valuable for the business, and so on. And I think AI will be able to help not just on the coding part, reducing that coding time even further, but also helping when there is disagreements and when people are discussing and when they're having these meetings, come up with the specifications based on the discussion, based on the different viewpoints, be able to do automatic research for each one of the valid points, and then weight them and measure them and present them to the team so that making those decisions is potentially even easier than it is now, where if someone proposes something they have to pass, they go on their own and they extensive research and do some prototyping or something and present something to the team, or it just becomes a war of opinions without really proof. So I think AI will not just help on the coding piece, but will also help in the management or team agreement or some of that chore that humans have to do once they have ideas and they have to convince other people that they are good ideas. Right?
Okay, let's pass the mic to Isaias. Isaias, if we don't do formal verification of our own code, why do you think it's important for AI-generated code? Are you need an integration test not enough?
Well, integration tests aren't not often enough, of course. So we need at the very bottom those unit tests in order to make sure that the smaller building blocks that are very complex do what they should do, and integration tests required to make the bigger parts of the system work together. And well, the AI generation can help us to help generate a lot of code of most of the parts there. And I'm not 100% certain. Why important for AI generated code? Yeah. I'm not 100% certain if formal verification of our own code would help there, to be honest. Maybe someone else has a take on that?
Sure. I have a take on it. I have a take on many things.
And let's finalize the answer with what's the dog breed that you will call for the class, the FP class.
Use a dog breed. All right, let me think about that in a minute. But here's the thing, though. It's a good question. Why is integration testing not enough? It has been enough for humans for a long time. Why should we change our standard of correctness beyond integration testing? My reason for rejecting integration tests at the output of the AI is because, today I have a very reliable QA engineer who's sitting there, writing these integration tests for me. And, she is thinking about everything around the system. She's looking at corner cases. She's doing all of that. What I sort of see in the future is, people are just going to rely on AI to generate their own tests, right? And, I think you have to do that anyway. But then you have you're kicking the can down the road one step, is that, are my tests meeting my specifications? And is that correct? Is that process correct? So the more I have AIs do things and the less I have humans do things, the more, I have this problem where, the thing that the AI is producing, am I able to trust it? Today I certainly will not, when I use AI today, I have it generate the tests. I don't trust the tests because it is doing the tests based on the code that it wrote itself. And so if the code is broken, the tests are broken. And I can never trust that. Right. So at some point that has to stop, and I have to say, look, we need a stronger position for the stuff that the AI is generating. And by all means, let it generate the tests, but it needs to generate the tests from a separate specification that I have given it. But here's the exact specification, and your tests have to match the specification. Your code has to match the specification. Oh, and by the way, I would like a proof that the tests that you have written are, these three things are connected. So, that's my take on it.
What about the dog?
The dog breed for functional programming, I would say it's sort of like the greyhound. Lean, mean, and runs like hell.
Okay.
So.
Let's finalize with the dog breed for each of you. Okay. Come on, Isaias.
Maybe a pincher. They're like hectic and, squirrel. I found the problem. I think I saw the issue now. And, it feels a bit like that.
Okay. Jack?
Probably a poodle because, very high maintenance, constantly down the groomers, having to spend a lot of money on them, right? It's just a disaster.
Raul?
I always thought it was something like a ratón bodeguero. If you guys are from Andalusia, you know what that is, but something more similar in the Jack Russell type family. Very smart, lean, small, can adapt easily. That kind of stuff.
Okay. Okay, thank you very much. So big applause for them.